Hi there. Hey, my name is Larry Pesce, and I'm the director of research, just a few other hats at In Guardians, and I'm here to talk a little bit today about some RFID type cards from HID Global, and we're gonna do some HID card hacking here at KringleCon. First up, a big thanks to Santa for inviting me. You know, it took a little bit of time to get here. A couple flights. Masks, secret locations. Um, but many of my other presenters are saying it's pretty cold. But um, I'm from New England, and we get a fair bit of snow, and it's not as cold as some other places. But certainly, it's still jeans and t-shirt weather here at the North Pole, even though it is a little blustery. Now, you don't want to stay outside for very long, but certainly it's still quite reasonable. So a big thanks to Santa for the invite and for the hospitality. All right, without further ado, let's start looking at the HID Prox 2 from HID Corporation. So the HID Prox 2 is based on some low frequency RFID based technology. They are fairly simple. They don't have any security mechanism to them. Uh, you read the card and they typically spit out a unique number of some sort. Uh, they're incredibly popular for physical access control, for gaining access into various organizations, uh, typically door access, whether that be potentially into the front door of a multi-tenant facility, into office suites, and potentially even into some secure data centers, and I'm using air quotes here for secure, it, to restrict access into specific locations where there may be some more sensitive types of things that we need to restrict access to. Okay. They are, in fact, typically low cost. There are a couple of different solutions within HID's Prox product line, but we're specifically going to be focusing on the HID Prox 2 specifically, from some quotes from Stephanie Ardili, the product manager at HID Global, who states that legacy 125 kilohertz, that's the low frequency, proximity technology is still in place at around 70 to 80% of all physical access control deployments in the US. And it will be a long time before that changes. And absolutely, I can see that figure based on the number of times I've gone into facilities and seen the HID-Prox 2 solutions, as well as the being for a long time. Typically, these installs going into organizations are those that um, are a fixed asset, and there's no push to replace them, given that they're installed, they're working, and it will be fairly expensive to make that happen. Oh, hey, so what does it all look like? Well, we've got a couple of components to the system. On the left, we've got our HID Prox 2 reader, where we present the card to the reader, and the 125 kilohertz RF energy transpires. The card is activated by the presence of RF energy through some capacitive inductance, and the card activates, spits out a number, and in this case, access to Santa's workshop. Now, the unique number from the card is translated via wire to some sort of controller that is the part that is checking for which numbers are allowed into which doors, and then triggers the unlock events for those doors. Now, on the wired side, on the back of the HID-Prox 2 reader, it gets translated to the Wiegand protocol, which is a well-known, well-documented standard that is unencrypted on the back end. So, potentially in some of these systems, we have a couple of other opportunities for us to interact with them, and not just on the RF side. We could potentially intercept that Wiegand protocol on the wire, or we could potentially find somewhere on the network uh, the systems that are potentially integrating with the door controllers for the read of the badges and the unlock codes. Typical Windows or Linux-based system that would be subject to various network traditional type of pen test attacks on the network. All right, so let's take a look at the cards themselves. Well, the cards themselves do provide us a little bit of information. Uh, when presented to a reader, when activated, they do spit out a unique number to the reader, which is then interpreted and sent Wiegand protocol to the controller, which verifies, hey, this card number is allowed into this door or not. Um, on the card itself, there are some numbers printed. There are the two numbers being the unique card identifier and the sales order tracking number. Now, for the most part, that sales order tracking number is not particularly useful to us, uh, but that card ID number is. That card unique ID number is intended to be unique per card. Um, but if we can read that physically, that doesn't make a whole lot of sense for us to have that be a secure mechanism. But what really happens is that card ID number is combined with a facility number or a unique, purchaser or a unique location facility number, which is not printed on the card, and it's only inspected and transferred in the air when read. So a combination of a hidden facility number and a unique card ID number that is printed on the outside of the card. One of the things that I think that's pretty neat about what HID did, and potentially comes back to bite them a little bit, is HID didn't develop their own RFID based technologies. They actually used some RFID technology that was already out there from Atmel, specifically the T55 57. And also, I think the new one is the T55 77, which, to the best of my knowledge, is backwards compatible. Now, the thing that makes this interesting is that the Atmel T5557 chipset is publicly available and it's usable for other purposes and is readily available in the market. And HID Global just decided to adopt this chipset for their application. What that means is that we could potentially purchase other cards from other systems that are leveraging this chipset to be able to use within our HID Prox Card 2 supported systems. All right, so looking at that data format, for what is spit into the air, comprised of that facility code and the unique card ID. Uh, the facility code is between 1 and 255. 0 is reserved for internal HID corporation development and so forth. And then the unique card ID is between 1 and 65,535, where 0 is reserved for HID's internal stuff as well. So we have a facility code between 1 and 255, and for each one of those facility codes, we can have a unique card identifier. So I can walk up to a facility and see two different cards out in front of the building. Maybe someone's wearing them, and note that they have the same card ID. In fact, likely in this case, the facility code is different. And we'll talk a little bit about some of those facility codes and the card IDs. So once that data is on the card, we print the card ID unique on the outside. We've got our facility code. That data is then encoded and then happens to be encoded to a length of a 26-bit data format. Um, and then at the reader, it fits conveniently within a single Wiegand protocol 26-bit data format. So it fits nicely for one packet. Now, some of HID's later adaptations, the HID Corporate 1000, um, has the ability to have longer facility code and card IDs, resulting in longer output of between 34 to 37 bits. But it doesn't have any additional security protections. It is specifically related to the availability of the quote key space, those unique identifiers. So how would I interact with some of these HID cards and readers? Well, there's a bunch of tools out there, but arguably my favorite, and even my favorite out of the Proxmark versions, the Proxmark 3, the RDV2 version. Uh, so specifically, the Proxmark 3 is a tool for interacting with RFID, both high frequency and low frequency, for doing some really deep analysis as well as some utility type of application for interacting with various RFID tags. And in this case, we're specifically focused on the HID Prox 2. Hardware was the original Proxmark 3 designed by Jonathan Westhughes and software by Gerhard Decoding Gons and a few others as well as part of the project. And the software and hardware has seen some evolution over time. The thing that I think that is fantastic about the Proxmark, while it's complex potentially in its usage through the tethered software, attaching it to our computer, it gives us the ability to read tags, interrogate them, find out all the values, find out its feature set, capabilities, and even determine its types. It has also the ability to become a card, a tag itself, meaning it can receive the data and then transmit that data back as if it was an actual card. Okay. It's typically USB based when we're interacting with it with the Proxmark 3 software. It does also work in standalone mode. We'll cover that. But typically we're interacting with it over USB to manipulate the device with the Proxmark 3 software. And that Proxmark 3 software has multiple different options, and some of that evolution over time. Um, and one of the more prevalent is the Iceman version of the Proxmark 3 software. We've seen some from Brad Antonowitz introducing the ability to do brute forcing on HID cards with ProxBrute, and even some potential interesting custom versions for the Holiday Hack Challenge. All right, so with the Proxmark 3 attached to our computer over USB, using the Proxmark 3 software, we can in fact read the cards, get their unique values, and then get the Proxmark 3 to replay those values into the air, acting as if we had the physical card. This allows us to effectively perform cloning type of attacks. Now, we can do capture and effectively replay, and we can do capture and push that data to a brand new card so we can actually have physical card medium as opposed to this piece of electronics. Now, there's no prevention for anyone for reading these tags. We just need to present it to the reader. And in this case, we're connected to the Proxmark 3 software. We've got our Proxmark 3 connected via USB, and we issue the low frequency HID read command. It reads a card present to the antenna in very close proximity, and it tells us that it's a 26-bit HID, gives us our facility code of 149 and our card number of 64899. Okay, and then some raw data down on the bottom with lots of leading zeros. And if you take a look, the card that we read over here on the right, we do have some values. Printed on the card is 64899. And then the 11261137-1 being that unique purchase order tracking number. So the unique number for this card was 64899, which we recovered as the CN with our low frequency HID read. And we also recovered that facility code, the FC of 149, the part that's only inspected in RF. Once we have that data, we can use the low frequency HID simulate or sim command and use some raw data to spit those same card values back out into the air from our Proxmark 3, and then present our Proxmark 3 to the reader, which the reader thinks a valid card has been presented. In this case, we are using the raw data with the leading zeros trimmed off. So you note on our LF HID read, we have that raw data at the bottom with a bunch of zeros, starting 2401. We just use that 2401 for the replay for the raw data with the low frequency HID simulate. So super easy, read and effectively replay. We can also clone to a new card. Now, the standard HID-prox2 tags are not writable. That facility and ID code cannot be changed. They're read-only cards. But as you remember, they are commodity Atmel T5557 or T5577s. And there are some enterprising firms that have purchased these Atmel chipsets and provide them to the consumer in a quote magic version, and I'm using air quotes here, to make them writable. Now, they're questionable in how HID wants folks to sell these, but they can't do a ton of restriction because they are a publicly available chipset from Amazon, from Atmel. And I've had really great luck in being able to find some of these, both through eBay and Amazon and Amazon Prime today, by searching for writable T5557. And sometimes you'll get the models that come back of the T5577. Okay, so how would we actually write this to a new card? Well, first one, instead of doing the LF HID read, we can just do LF search, and it tries to find all of the possible low frequency card present to the antenna. And in this case, it did find that we had that same HID card with the facility code of 149 and the 64899 for the unique card identifier and its raw data. So it attempts to read all of the low frequency tags and until it discovers one. Once we have that raw data, we can write that to a new card with the low frequency LF HID clone. And the clone is not simulating that data into the air. It's actually pushing it to a new blank card with the T5557 chipset and writing that raw data to it. It says it's preparing to clone. You present the card, it writes the data, and then you have a new physical card. All right, it is possible to do standalone cloning or capture and replay because, well, if we're going to do a capture and replay, that device, it's really small, fits in the palm of your hand, but it's now attached to your laptop with a USB cable when you're issuing some commands and so forth. And that's not very stealthy. That's quite obvious to surreptitiously bump into someone on the bus or outside of the building. Uh, and you're going to get caught doing that type of stuff. So the Proxmark 3 can also perform untethered cloning, meaning if you provide it with some power, like a portable USB phone charger type thing, or the optional internal battery for the RDV2, we can power it and then use that one button on the Proxmark 3 with the various sets of key presses to read HID tags. And once it reads a tag, it will automatically start simulating, just like issuing that LF HID simulate command for the most recent tag that was read. So, and we can do that with that small device, battery powered in the palm of our hand. The challenge becomes, what happens if we read a tag with the unique identifier and a facility code? And typically that facility code is going to be the same for every that run of cards that we order. So let's say Santa's Workshop, facility code 149. Every card that has access to Santa's Workshop will typically have the facility code of 149, and the unique card identifiers are the part that change. Now, it is possible to buy cards um, that are randomized, but you definitely pay a premium for that. And I've only encountered one organization that has ever fully admitted that uh, they randomized all of their facility codes and their card numbers, and they said they paid exorbitant amounts of money to be able to make that happen. Now, part of the reason why they did so is if you think about how you're buying your cards, you're getting them in, say, a chunk of 100 or 500 cards, and they're all shrink wrapped. You open the shrink wrap, and then uh, you start programming the cards. And the first your first card out, you program the system, and that's the security team, meaning the physical security team. They have access to everything so that they can do their inspections. And then maybe you end up with the C-level executives, and they have access to everything. And then you start moving down the chain. You have your computer administrators that need access to the computer room, and then you get down to your administrative assistants and your interns that just need access to the front door. But let's say you recover a card, and it's for the administrative assistant. You can get into the front door of the multi-tenant facility. You can get into the office suite, but you present that card to the data center door, and it doesn't allow you in because now you have the card of a lower privilege user and you need to elevate your rights. Well, if we think about that, that's that administrative assistant that has likely gotten that card, towards the end of the run, meaning they have the higher number. So if we think about those cards that were delivered, they're typically sequentially numbered. So if we look at this one here, up in the top middle, we've got 15573, and then we go over to the left, 574, 575, third one in, go back one, 576, 578, 579, 580, 581. There's no 577, but I'd argue that it's probably the card that's turned over in the front here, where we can't see the number. So they're sequentially numbered. Maybe they're a little bit out of order. Maybe we dropped them as we were taking a couple of them out. So they're close. So if we can read one card and recover the facility code, maybe we need to start guessing other card numbers because the card number that we read doesn't provide us access. But those with lower numbers, and in some cases higher numbers, usually lower numbers, will allow us to get into places where the card number that we read doesn't allow us to, but read using that same facility code. Okay, so with that, thinking about some of those facility codes and those card numbers, I do very much encourage you to have fun during the Holiday Hack Challenge and explore the use of a Proxmark 3 within the challenge. And a huge thanks to the Holiday Hack Challenge team that puts all of this on and spends so much time crafting this game and you know giving this to the community during the holidays. So, and again, a big thanks to Santa and everyone involved. And please enjoy, and we'll talk to you soon.
Ho, 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 ho.